Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics. Welcome to Speaking of Reliability. This is Fred Schenkelberg.
And this is Carl Carlson.
Hey, Carl. You know, we were just chatting a bit about FMEA stuff, and it reminded me of one of the early days I taught a reliability engineering management course. And it was for the Nav Air reliability quality team. And this was a long time ago. And I actually stayed in touch with a handful of them. They moved on and actually became really well-respected reliability professionals. So that was kind of nice to see happen. But at one of the lunchtimes, and I probably have told you this story before, at one of the lunchtimes, one of the guys came back in and he had a vanilla envelope that he had just received in the mail. And it was probably an inch thick. So it was a big packet of some report he was getting. And I said, well, what's that? Is that like your afternoon reading or something? And he goes, oh, no, this is an FMEA, a design FMEA for a wing structure of an upcoming aircraft we're working on. Oh, that's interesting. Why is it so thick? And he goes, well, this is only half of it. They left out the other half. And I think I'm expecting that tomorrow. And he judged it by the weight. He kind of held it up, and I don't know if he was joking or not. And he goes, yeah, I know this isn't complete because it's not thick enough. Oh. And I'm like, what? And he says, well, they have to check, and analyze every rivet, And I says, well, how many ways can a rivet fail? It's like, well, they have to list them all for every rivet in every location. Are you kidding me? And so I went on a rant about what a waste of time. But I've learned better since, and not rant as much, but just say, that's really not that useful. Why don't you think about this?
Oh my God, you got me spinning with stories and principles that are just flashing through me right now. I have one quick story is in the same thread is a brake energy recovery system. I won't mention the
this is where I had a Prius and they had that system. So if I was coasting, the battery would charge.
Yeah, this is one that was not an electrical system. This is a brake system, conventional, that would take they had a bladder, and when you put the brakes on, it's like, imagine a delivery truck.
Mm-hmm.
Put the brakes on, it increases the pressure in the bladder, and then it uses that pressure to accelerate.
Oh, that's clever.
It was an interesting concept. Of course, we all know from entropy and all the rest of it, you're not going to be able to do that forever. You're going to use some energy. You have to add energy into it. But It was a recovery of energy. And I got brought into the project a little bit on the late side, I would say, because they already had a system. They already had an FMEA that was this is, I can't believe I'm saying this. It was 1,000 pages.
Well, if it's not a whole ream of paper, what's the point of doing it, know?
And I think my brain is going, what a complete waste of time, because no one's going to be able to go through 1,000 pages, even if you had some type of artificial intelligence interface, which they didn't have back then. This is many years ago. I said, okay, let's set that aside, and we're going to do a system FMEA. They were late in the product development process, so I had to speed up. I said, let's get everybody on the phone, because they're suppliers from different places. Mm-hmm. And let's find out just the most critical failure modes, and let's make sure we've addressed those so we don't have safety issues, etc. And we did that. It took maybe almost a day, and we got a very good high-level critical failure modes list and an FMEA form. But I've seen so many FMEAs that are useless trivia of just listing everything. And it doesn't have necessarily any risk involved at all. So I use a rule of thumb, Fred, that I tell people, which is if you have the right team of people, if no one's concerned about a failure mode, I wouldn't even bring it up.
Yeah. Part of the brainstorming is to, air everything out and you get some of those, but it doesn't require them all to be on the sheet of paper or you get added to this thing.
That's the point.
Because if you make the judgment that, the chance that a squirrel's going to eat through that bladder in that repair system and it's encased in a metal can underneath the vehicle or something like that, that's, yeah, that might happen, but let's ignore that and just move on.
Yeah, there has to be some judgment, and that's why I love teams. But you got to have the right people in the room to make that judgment. But otherwise, you end up not seeing the forest for the trees, and that's more dangerous. That is higher risk than the other way around, which is
try to do everything and go through the motions of it, and then not able to even parse out what it means.
You don't have the bandwidth to address the most serious areas.
Yeah, we just spent 3 weeks doing this, and now we don't have any resources left, and we got to ship tomorrow. I went into that, but it wasn't really what I've seen with the bottoms up approach way too often is that it's to check the box. It's a standard. You got to do it that way. Well, how are you going to use this? Well, we check the box that they did it. And like, well, how are they using it? Well, they're not. They're doing it because we're going to check the box.
Let me introduce the bottoms up topic, because I know we talked about it prior to hitting the record button. So what Fred's talking about there is there's two approaches that are introduced in some very early FMEA standards, like 1629. One is top down, one is bottom up on FMEA. And there are a lot of instructors still state that FMEA is either top down or bottom up. There's two approaches to FMEA. In fact, 1629 uses that language, that these are different approaches. And what the bottom up is you start at the bottom of the system hierarchy. And so you take a component and you say, okay, if that component fails, what's the cascade? And basically you're looking for where you have single point failures or the mission isn't accomplished, things like that. And you end up with a very long exercise of going through every component to trace what happens if that component fails. And then separate from that, you do a top-down analysis, which is more functional. What's the system or subsystem or component supposed to do? And then do a FMEA on where it doesn't accomplish that function. And you end up with this controversy as to whether FMEA is top down or bottom up, or we're going to do a top down today, or we're going to do bottom up.
Yeah.
And that's really one of the things I would love just to hash around with you is do you or I, or anyone else that's listening, advocate for a bottom up FMEA exercise?
Yeah, I certainly don't. And I have at some occasions when we have the team already knows that this particular device, it's like in inverters, there's a IGBT, I think is the name of it. And it runs hard, electrically speaking, and it creates a lot of heat, and it's kind of the Achilles heel of an inverter, or at least used to be. I'm hoping the technology's moved on. At that point, the team already knew that was where we got to focus. So we went straight to the component and how does it fail? What can we do about it? Everything else. So it was basically a system FMEA on the effects of this one component. And it was appropriate because it was already, we knew that component, but all of the little capacitors in the digital part of that circuit, we never talked about. Yeah, they can fail. And some of them, they'd fall off the board and we'd never know. Nobody would know. And other times they'd fail and fall into exactly the wrong place or be part of a sensitive circuit. Yet we had an elephant in the room. So we went straight to that. And so it was kind of a blending of those, but the vast majority of time I've heard the argument, well, if we don't check every component on the bill of material, every screw, every rivet, all this other stuff, how do we know we've been complete? And I look at them and I say, it's because that's why you're in the room, is you have engineering judgment along with these other people. We didn't randomly pick people off the street to go fill this in, or a piece of software to do it blindly. It's your judgment that makes the difference, that this is useful. And
Fred, that is music to our ears. That's just, you're so absolutely right about that. The human judgment of the team members is a critical part of successful FMEAs. Otherwise, you're trying to FMEA everything, and that therein is the problem. Is you can't FMEA everything. No one has the time, the bandwidth, the energy, the money to do FMEAs on everything.
Well, that's where the software guys were advocating the bottoms up, because they had these huge databases saying, well, capacitors fail 3 ways. They go open, short, or intermittent. And we can fill that in automatically. So you can quickly do the bottoms up approach because we've automated all of it. And I think they really miss the principle. These software packages like that advocate doing that is you've just stripped out the reason you have a team of expert, people familiar with these systems to talk to each other. And they're like, well, our customers want it because they have to complete it this way according to the standard. And again, you're just missing the point.
I'm
here, guys.
so tired of doing things because the customer wants it. Yes, of course, you have to live with and satisfy the customer. But how about we talk to the customer and explain the principles involved and work with the customer to get this what they want. They want a reliable, safe product.
Right. If you wanted to kill 2 trees to do an FMEA that took you 6 weeks and is meaningless, then is that what you really want? I've had that discussion a few times. And
yeah. So let me also mention something about the bottom up that has value. I'll actually introduce this with when I do FMEAs on a program or a project. I like to start with a system FMEA. First of all, you have a system identified before you have the components identified, and so you may not have the design, the component structure totally, but you do have a system architecture. And using a system FMEA, you can identify which subsystems and then later which components are of most risk.
Yep.
Because you can use your severity and occurrence ratings and detection if you're using detection to prioritize risk. That helps to identify which components rather than doing them all.
Yep.
And so I often get a list of critical components from a system FMEA or a subsystem FMEA, and then those can have follow-up with a component FMEA. And yes, the failures of the component specifically, and I'll use the word failure mechanism, the mechanism of failure can then propagate up through the subsystems and up through the system, and you can trace that, and then you can assess that risk of that component failure on the system as part of what I'm describing. That's different than doing a bottom-up on everything.
Oh, yeah, very much so. And I call that approach, and it's not bottoms up or tops down, it's nested is the way I call it, is you do the system one and you go, oh, this power supply piece here has got a lot of problems with it. We need to dig deeper into that. And I'm picking on power supply because that's been it's an easy target. It's an easy target. And then the worst thing you can do for a power supply FMEA is invite only digital electrical engineers, because they only get to talk about 1/10 of the circuit and the rest of it's just magic to them. But I digress. Is get the right people in the room. That still matters. But
yes.
So we do a system one, we might end up with 1 or 2 parts of subsystems that are like, yeah, we need to dig deeper into that. And then we get 2 other teams together for those subsystems. And then they might say, oh, this part of this part is this key component that we got to figure out. And then I often find is that we'll spin off 1 or 2 FMEAs on part of the process, because one of the high risk areas is the variability of assembly, for example. If we don't get that right, then this isn't going to work. So let's focus on that and get some assembly folks in the building on the team. But I don't know, is there a proper name for that approach of, start here and then spin off different teams?
Well, first of all, I wrote down the word nested that you brought up, and I like that concept. I've not used that word, and I like that word because there's some type of iteration that's inside the bigger system, and so that really kind of makes sense to me. And I don't have a word for any of the other concepts you were describing, but I'm definitely going to use the word nested from now on. So if you allow me.
Oh yeah, no problem. I probably learned it from somewhere, but the idea is that if I can do 5 2-hour FMEAs and I don't try to do one 50-hour FMEA, I get way more value for the team and for the design and for the process. And it gives you the flexibility, one, of getting the right people in the room, depending on what's the scope of that particular FMEA that you're breaking open. That's always been useful for me.
Let me bring up one other problem with bottom-up approach. The bottom-up approach doesn't start with functions. And they say, okay, well, we're not doing a functional FMEA. And I counter, all FMEAs are functional.
Yeah, because if at the end of the day, if that failure mechanism occurs on that capacitor and nobody cares and it doesn't matter, we should not ever have been talking about it.
Yeah. And when we're doing, let's take a bicycle, and let's say we have a brake pad. Certain type of bicycle still has a brake pad. Mm-hmm. Okay, so if you're doing a quote bottom up, they would say, okay, the brake pad, how could it fail? No, I want to know what the function of the brake pad is. I'm going to start every FMEA with asking, what is the function?
Yep.
Like the brake pad, it's got certain functions. It's got to provide friction under certain requirements. So even though it's a component, doesn't mean you avoid the use of function. So I don't want to hear people talk about functional FMEA versus bottom up, because to me, all FMEAs begin with the item and the function, whether you're a component, subsystem, or system.
Yep. Yeah. Yeah. I can imagine that if you did a bottoms up and they spend 3 hours just on the brake pad and they're talking about UV degradation of the material, insect infestation, if it gets dirty, it gets oil on it, and on and on and on. And they completely lose track of the point of the brake pad is not to be a nice shiny brake pad there.
Yeah.
It's to actually do something.
Well, yeah. And the definition of failure is the manner in which the item does not accomplish its intended function.
That sounds like from a book somewhere. Did you write that?
And so if you don't know what the function is, you're not going to get the failure modes.
That's
and I want to make one other comment, because you introduced this topic really in an interesting way, and I agree. There are some people that say, as part of FMEA, we're going to list all the failure modes. And that's really, that verbiage is in some standards. Mm-hmm. And I push back on that, because I can brainstorm failure modes to infinity. Like you pointed out, are you really worried about the squirrel eating through
this metal housing?
The metal housing. Are we really worried about? We should be worried about the things that people are concerned about, that are smart, the smart people, the ones that are subject matter experts in the room of the FMEA. I also point out that if one person is concerned, I don't vote them down.
Right. No, it's not a popularity contest.
Yeah, exactly.
Yeah.
Because very often the one person is in the minority and they turn out to be right.
Yep. Yeah. No, I've run into that a number of times where, like you had way too many stories I'm thinking of on this, but it would come back. But the idea is that, I hope on your this committee you're working on, you can wrestle that off the table. It's like, no, let's go with nested. Introduce a new concept to them, new term. Say it's an ancient bird habitat technique.
Yeah.
They start with what's important. It's attachment to the tree, and then they work out from that. Well, some birds do. But the idea is you start with the primary function. We want to create a house, and let's start with the basics, the functions first. What is it supposed to do? And on and on and on.
Yeah, exactly. So this is a very important topic because one of my passions is that FMEA becomes useful and valuable. If it becomes watered down to try to do everything in one form, then you're going to miss the forest for the trees. It becomes valueless.
Yep.
And so I feel really strongly that we have to protect the value of the method, which means it's not a method to fill out a form. It's not a checkbox. It's not a do everything. It's also not one size fits all. Like we're going to do FMEAs always. There has to be a reason to do the FMEA.
Right.
So those are some things I just keep preaching, and I know you do the same.
Yeah, and I'm quite sure some of our listeners agree with us vigorously, and maybe there's one or two of you out there that's like, no, that's not the way you do it. Well, what's your defense?
Well, yeah, please speak up.
Let us know.
Let us know. Do you use bottom up? Do you see value for it? What about this subject we're talking about? Should FMEA be one massive document that includes everything, or should it be targeted based on some type of preliminary risk and methodology? We want to hear from you. We will not shout you down. We want to hear discussion, and even if there's a confusion about it, we will take it up with you and maybe turn it into a podcast.
Yeah. And I'd really like to hear what's working. And it might be maybe somebody's got a cooler name than nested FMEAs. That'd be cool. Let us know. Head over to accendoreliability.com/go/SOR. There's a couple of ways to get in touch with us. Carl and I and the other hosts of the show are available through LinkedIn and our About pages. And I think this is, according to my log here, this is episode 960. And we're getting close to 1,000. And we've never done a process FMEA on the show, on all the mechanics that make it work.
Well, okay. We could do that.
And I'm not going to worry about all the components in my laptop.
I hope not.
All right. Thanks, Carl. Good luck with your committee on this one.
Thanks a lot. We'll see you later.
Cheers. Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.